And happy Wednesday. We have, well, let's see. Today, we're going to talk about a rather large data set, a municipal data set um, from New York City, or the from New York City, and we're going to spend time on this to follow up on what we talked about on Monday. I get migraine headaches, and I have a migraine today. So please bear with me. It's just one of those things I've dealt with since I was a kid, right? If anyone gets migraines, I have a lot of personal experience about triggers and all sorts of remedies. I am not allowed to give you medical advice, but certainly decades worth of experience with migraines. If I can be helpful with that for anyone, please contact me outside of class. All right, so why don't we get started? All right, but before we begin, the usual administrative bits. The reading, still there. Again, I set deadlines on the reading to give you a semblance of pacing with the material. And on Friday, we'll be pivoting to probability distributions. And that's in support of something called max likelihood estimation and inference, an important aspect of data science that leads or gets towards modeling. And then after that, we'll spend about maybe a week on distributions and MLE. And then after that, we'll go to the extraction of insights, namely various machine learning methods. And so as of today, we have 5 weeks plus 1 day left in the semester. The last day of the semester, if the source I checked is correct, is May 2nd, which is a Tuesday, and we will have our last class on that Monday, 5 weeks and 1 day from today. Project number 4, I have it right here, and thought about it, and I'm going to score the written part as homework number 2, and I'll talk about what that is. I have the PDF, or rather the Word file, here now. And this project is going to be more of a thought project because you're going to spend or invest time in considering the people who touch the system we're going to talk about, namely the ride-hailing system for New York City. And you're going to be posing your own question that you'll then, for which you'll do the analysis to arrive upon an answer. Okay. I saw your assignment submissions last night. Thank you for all of your work. Any questions? No? No questions? All right. So when we last left off, we talked about the fact that when you're given data, you have to kind of beg the data for what you want. And by beg, I mean certainly you're imagining all of the principles, the entities that touch the system, and you're going to use that to design the questions that you're going to answer. And these are limited by the measurements you get, right? Because when you're given the data set, you don't get to decide what that data is, right? You have what you have, for better or for worse. And that might involve going off and finding other data sources that you need to augment what it is you're trying to accomplish. But certainly understanding all of the entities or people, roles, or principles that touch a system helps you in the design of a population in order to answer questions. And when you answer these questions, in the case of the data set we're going to talk about today, you're gonna be adopting the posture or pretending you're one of those people or cohorts that you've described in your population. And so when you're given an existing data set, oftentimes that data is for the purpose of the organization that furnished it to you. And more, as you can imagine, it's getting really hard to get access to various types of data. Fortunately, federal and municipal data is often readily available because of the Freedom of Information Act. There are certain types of data that they're required to make public. But many enterprises, companies, and organizations, universities, things like that, they often view their data as part of their competitive advantage. And it's really, really hard to pry that data from their hands unless you're directly involved in the analytics team for those organizations. But nonetheless, you don't have control of the sampling. So you can't place samples. You're given the measurements that they've made, these vector instantiations, and you effectively have to beg the data or ask the data for what it is you want, supplementing it with other sources that you can find. And that supplementation means doing all sorts of alignments with APIs like the Merge API that we saw a few modules ago. And so you don't get to design the population, but you can still take a look and understand the data source and design a population from that after you've gotten those or obtained those data sources. And you don't get to place the samples. Those samples are given to you, but nonetheless, you can study the problem, you can study the data, and certainly design a population, hierarchical population consisting of maybe it's overlapping, maybe it's non-overlapping subgroups in order to frame the problem from some perspective. Okay, refreshing your memory from last time. Any questions about this? No, no questions. Makes sense? It's Wednesday morning. Yeah. I swore yesterday was Wednesday, so I'm off by a day myself. And so we talked about this idea of framing an issue, looking at the system understudy, and coming up with a list of stakeholders. And the stakeholders are those that touch the system, and people can interact with the system on three, at least in our class, three major ways: as users of the system understudy, as operators of the system understudy, as managers of the system understudy. And it's not to say that these three cohorts that touch the system, the stakeholders, they could be non-overlapping, or depending on the system, they could be overlapping. So for example, at an organization like Clark University, somebody who is an employee, an operator of the system, could also be a user of the system, could also be a student, right? So it's really important to think about how you view the stakeholders and make those decisions about whether or not these subgroups for these stakeholders in your hierarchical population design, whether they're overlapping or they're non-overlapping. Okay, any questions about this? No? Makes sense? And so when we talk about the questions leading to that, we want to evaluate the impact that the system or these stakeholders have on the system, right? And your questions are going to arise out of an analysis of this impact. Now, it's not always so straightforward, and that's on purpose in this assignment, because that is more close to what happens in the real world, where you're given a data problem that you're trying to solve. And so all of this depends on the measurements that you're given, and that's going to be the example we're going to adopt. And so the example is New York City, because the data is available, and it's a very complex system consisting of a lot of parts. And I always like to begin with multimedia. So you'd hear music in the morning. Yeah. All right. It's enough of that. So New York City is not very large geographically as far as urban expanses go, but it is the largest city in the United States. And this is where we left off last time on Monday. Its land mass is only 300 square miles, but it has an enormously large population density, over 29,000, could round it 28,000 people per square mile. That's a lot of people, right? And when you have so many people in one location per square mile, you kind of run out of space in X and Y, so to speak, if you were to impose a coordinate system. So you only have left Z direction. So if you've seen New York City or been to New York City, you're going to spend a lot of time looking up if you've never been there. There are a lot of very tall high rises, and many of them contain housing, apartments, both things that are rented as well as apartments that are owned, condos, I guess you could call it, as well as businesses. And so the population total in New York City, and I'm sure it's a little bit larger than this now, based on when I got these numbers, is around 9 million people, which is absolutely huge. To give you a sense of perspective, the state of Delaware, its population just touched over 1 million people. So there are more people, ninefold as many people in New York City for each person that is in the entire state of Delaware. So it's a very large population squeezed into a very small geography. Now, in New York City, as you can imagine, with that many people in one location, you have a lot of demand for basic staples, both durable goods as well as dry goods. And supply and demand, basic business principle says, if there are more people chasing a finite number of resources, you're going to have a higher price. And for that reason, New York City, for the same items you would get elsewhere, New York City is much more expensive. It's a very expensive place to live. And so a lot of people are leave New York City and they go all over the place. The largest destination for people leaving New York City is the Southwest and parts of the South. Certainly, the retirees go to Florida, and some of them go to nearby Boston, another medium-sized city. But nonetheless, it's still very popular because, especially among young people, the growth rate, while moderate, it's still positive, about 0.71% increase in the population. And that's mostly due to the abundant jobs in New York City. Now, New York City is the epicenter in the United States of the financial markets. Wall Street is there. The NASDAQ and the New York Stock Exchange is there. So there's a lot of international business that transacts in New York. New York City is also a diplomatic hub. The United Nations physically is located in New York City. And because of the population density, it's also a commerce hub. The Port of New York is very large. And in fact, you can get just about any international product you can imagine in New York City because you have so much population and there is a relatively large percentage of recent immigrants in New York City. And so the growth rate is positive. The household income is just over $102,000 a year, and that might seem like a lot. But in New York City, because of the cost of living, this average, and the average, you know by now, is not a very robust statistic. The median is a much better representation of central tendency. But nonetheless, it might seem like it has a relatively high average household income, but your dollar buys you less in New York City than in other locations. And so the poverty rate in New York City is about 17%, which is very, very unfortunate because that's almost 1 out of every 5 lives at the poverty level. Now, when you read statistics, both federally and statewide, about poverty rates, it's really important to adjust that based on the actual cost of living, so-called livable wage. The livable wage is often much larger because the realities of things like staples, food items, and transportation and things like that is very different just in this 300 square mile landmass relative to the much larger landmass of New York State. Okay. Any questions about this? No? Now, of course, with all these people jam-packed per square mile on average, of course, the only way to get services and goods and go about your business is to operate this thing 24 hours a day. And I remember years ago seeing a documentary where somebody went out in the middle of the night and enterprised to find out at like midnight and beyond to about 5 a.m. What can you do in New York City? And you can do just about everything from booking travel to buying clothing to grocery shopping, all sorts of things, you name it, you can do it in New York City. And it kind of makes sense because if you have so many people jam-packed into one area, you can't possibly run the city with standard business hours from 9 in the morning to 5 in the afternoon. You need the full 24-hour a day cycle. In addition, as you can imagine, with so many people jam-packed into a relatively small location, you can't afford to have everyone with his or her own car, and even every family with that family, one car per family, because there's no place to put all of these cars given the high population density. Moreover, if all of these cars enter the roadway, you're going to get absolute gridlock and no one can get around. So there are certain municipal decisions in New York City to discourage vehicle ownership. And if you enterprise to live in New York City, it's really expensive to find a garage space, a place to put your car, because very often you can't put your car on the street because you're going to end up congesting the street where you could place moving traffic. And so oftentimes, if you look at the cost monthly for renting a parking space or a garage space, it's often as expensive as the monthly rate of renting an apartment. It's no joke at all. And so also the tolls in New York City to enter New York City are purposefully made much more expensive because they want to discourage people bringing their cars into the city. And so all of this, for these reasons, the public transportation system is the glue that gets New York City to operate. And there are various modalities. There's the subway, there's the train, like the Long Island Railroad and the New Jersey Transport that goes over longer distances. And there's also the cab system. Now, certainly, New York City has a lot of people in general, and it's a very densely populated area. But you also have regions around New York City, some examples, Stamford, Connecticut, and Newark, New Jersey metro area, where a lot of people commute via the longer range trains into the city, primarily to work in these industries like Wall Street, finance, banking, diplomacy, etc. Okay, any questions about this? No? So there's my spiel about New York City. Now, when the so-called gig economy, specifically for ride hailing, the two archetypes are Uber and Lyft. When they came to town, they expanded to New York City among many other metropolitan areas. And it kind of makes sense, right? You need transportation modalities, and cab rides are very, very popular. And it covers that gap where the distance might be too long to walk, but too short to drive. And so New York City became the epicenter in the fight between traditional cab companies. One of the largest ones in New York City is the so-called Yellow Cab Company, and these new data-enabled ride-hailing services like Uber and Lyft. And so with this, one of the arguments is that this isn't fair to the cab companies. And there's an organization in New York City called the New York City Transportation and Limousine Commission, or TLC. It's a nice name, NYC TLC. New Yorkers are, someone once described them as they're kind but not friendly. Kind meaning if like you're struggling with a piece of luggage in the subway, someone will help you carry that thing. They'll put it down and then go away, and they don't want you to talk to them, right? But nonetheless, New York City TLC, Taxi and Limousine Corporation, is the governing body that regulates ride-hailing services. And so before Uber and Lyft, these sort of gig-based ride-hailing services, it was just all of the different cab companies. And this NYC TLC establishes all of the requirements that one must adhere to if you're going to participate in ride hailing in the city of New York. Now, for the traditional cab companies, you need a license. And these licenses have a name. They're called medallions, and they're quite expensive because, as you can imagine, it's a lucrative business to be in. And in order to maintain these medallions, you have traditional employees, and as employer, you because they're contacting the public, they have background checks for those folks. They interview, and you get to know these people over the course of their employment for the medallion owner. And so these medallions are owned typically by the cab companies, and each one of the cab employees, the so-called cabbies, works for these companies that own the medallion. And so maintaining a medallion requires adhering to the standards, and there are regular checks about all sorts of standards, such as safety, seat belts, passengers, and things like that. And so it's important to set standards on the maximum number of passengers per car, because certainly you want to make sure you have enough seat belts for each passenger that might be riding. Moreover, if you have a minor riding in the car, you want to make sure he or she is riding safely should, heaven forbid, there be an accident. So they set rules for things like the maximum number of passengers in the yellow cab or green cab and the other cab companies, seatbelt rules about their functioning and the types of seatbelts. And then there's also, this one's pretty important, the so-called refusal law. During the history of cabs in New York, and cabs go back a really long time in New York, certain individuals from various demographics struggled and had a harder time hailing a cab, right? So it was an equity issue. And so now NYC, not now, but more recently, decades ago, they also set rules as it pertains to the refusal of a fare, a potential passenger who enterprises to hire that cab for a ride. Okay. Any questions about this? That makes sense? Yeah. All right. So they also set rules about safe operation hours. And airlines, pilots, and semi-tractor trailer trucks have the similar thing, which says that after a certain number of hours of driving, you have to stop and take a break or rest or sleep, right? And they do this because, of course, driving tired often leads to detrimental consequences that are worse than people driving under the influence. And so they really want to make sure that they're attentive. And after a certain number of hours of operation, you have to stop and continue on the next day. They also deal with so-called card swipe practices, rules about this, that the point of sale for electronic payments has to be in the back so that this payment method is not in the hands of the cabbie, so that you maintain privacy. And it also, they found, reduces instances of identity theft. Okay. Any questions about this? That makes sense? Okay. They also provide a formal venue for complaints or issues with the ride. Every ride is recorded, and every cab has a unique identifier, and it's known by the cab companies who the cab operator, the cabbie is. So if you had an issue with a particular ride instance, you can, with specificity, identify that particular service that you've used. Now, the data sets for NYC TLC, they're published monthly, and these are quite large data sets. They're actual municipal data sets. And the purpose of this assignment is twofold. This project, number 4, is to give you experience with the real data set from a municipality to deal with or have an instance, rather, of posing a question. Now, the analyses are more straightforward than previous analyses, but what's different is the size of these data sets. And these data sets will be between 5 and 10 gigabyte in size. Now, depending on your laptop, I don't think the computer science department sets any standards for minimum specifications for your computational device. So some of you will have trouble loading these files. And I suggest that you sooner rather than later, today or tomorrow, set up the ability to load these files to see if anything breaks, and then we can talk about other solutions for that. Okay. Any questions? No? All right. So hailing a cab, and I don't assume that you know the background. I can't make that assumption, so I'll take some opportunity to explain cab rides. Now, hailing a cab can exist in a number of ways, and this is for the traditional cab company. And yellow cab and green cab, the cabs are literally yellow and green, are the two predominant, largest traditional cab operators in New York City. And so you can hail a cab on the street. And typically, you are near a building or you're somewhere, you step off the curb, you see a cab coming, and you gesture, hey, sometimes shouting, whistling, if you can whistle. I could never do that, whistle. Catching the attention of the cabbie, and he or she stops and asks you where you'd like to go. You tell this person where you'd like to go. Then they set the so-called meter, which measures both the time and distance for the fare at a regular cadence and calculates the fare as you're driving. Now, certainly, they don't always stop for you. If there's already a fare in progress, they're transporting somebody, they're not going to stop. And typically, they signal to you either by lighting that sign on top of it. In the old days, they used to raise a little flag up to signal that there's a ride in progress. And they're not going to stop and pick you up because each fare, ride in progress, is a unique service or product. And they generally don't add people who are unrelated for a ride. Any questions? Does that make sense? All right. Another way to hail a cab is to phone ahead. You get the number of the cab company. You call them up and you tell them who you are, and where you'd like to go. And some point later, whatever cab is available in your area, they come and they pick you up. They start the meter and your fare begins. When it arrives at the destination, they stop the meter and whatever money has been counted based on both distance and time, that's the fare that you pay at the point of sale system. Okay, any questions? No? All right. More recently, there have been a number of apps, and that is in response to these gig-based concerns like Uber and Lyft. And these apps are available for participation for the traditional cab companies. And with this, if they choose to join it, you bring up the app and it looks just like an Uber or Lyft. And if you've never seen it, it gives you a map of the location around you using the GPS feature in a smartphone. It knows where you are, and then you select a cab. And when you do that, it summons the cab driver, and he or she then drives to the destination to pick you up. They start the meter, the fare begins, take you to your destination, stop the meter, and then you pay the fare. Any questions? Yeah, make sense? All right. So there are lots of modalities for which you can hire a cab. You can also sometimes call ahead. You can say, okay, at 4 o'clock, I'd like to have a cab ride from BP building here on campus, and I'd like to go to this address in Shrewsbury, for example. And so you can also call ahead to schedule them for specific ride times. So the employees of the cab companies, as you can imagine, there are a lot of cabs in New York City. And so you're going to hire a lot of employees. And you really, as a cab company, enterprise to protect your medallion. There's a lot of money wrapped up in it. It has a lot of value. Because it allows you to hire people to offer fares in this traditional sense. And so here comes Uber and Lyft. And Uber and Lyft sort of turned all of that on its side. And the model in Uber and Lyft is they treat the ride hail drivers as so-called independent contractors. As an independent contractor, you are your own business, and therefore the vehicle that's used for the ride hailing service is owned by you. Now, some drivers they rent, and I know Enterprise Rent a Car has a program where they basically loan you the money in order to rent the car over long term, like a lease. And then the idea is that over time, you as a driver, you would make enough money to be able to pay the lease. And then also make profit on top of that. And so there's also lots of controversy. I know there was a lawsuit and some litigation in the state of California about are these drivers really independent contractors? And if you think about it in the same way of, for example, hiring a plumber or hiring a carpenter, it's a company you call. They're providing a service for you, doing something, but they are their own business. You don't really tell them, show up to work at this specific time, do it this specific way. And so we're not going to talk about that argument, but what we're going to talk about is this relationship between the gig drivers, like the Uber and Lyft drivers, as versus the yellow cab company in this discussion about posing your question. Okay. And so one of the things that happens in Uber and Lyft is you bring up your app. We have Uber app on the left, Lyft on the right. They look identical. Just like the cab company app, it brings up a map of your geography, and you see these cars in real time moving around. And they get those locations from the smartphone that each driver has in the car. And so these drivers, as quote unquote independent contractors, they can choose to join the system or leave the system at their own pace. And theoretically, they don't really have hours defined for them. These drivers, when they get a fare or when you hail one of these rides, you go on the map and you enter in where you'd like to go. And it uses your GPS to figure out what your current location is. And then somebody, a driver in the area, picks up your fare. When they pick up your fare, two things happen. Information about their vehicle and their name is sent to you, and then information about you is sent to them. Now, when they get to the area, they drive around and they have a sense of who you are from the information given to them. And then you have a picture and description of their car, as well as a picture of the license plate. So, this word to the wise, if you hail an Uber or Lyft ride, check the license plate first. Don't just get in, right, for safety's sake. But that being the case, all of this data is swirling over the server's infrastructure for Uber and Lyft. And as a result, one of the pieces of information they collect is the demand at the time for their ride services. One of the ways they use this information is for so-called surge pricing. Whenever there is a high demand, they proportionately increase the rates for the fares for the rides. And they can certainly do that. And you contrast that with the meters in the yellow cabs, where they have an algorithm where at a particular cadence, they measure the time that has transpired and the distance it has driven and charges you regardless of the demand. And so because they have all of this data from all of these instances of the app, they can actually compute demand and proportionately raise the price based on this demand. And so if, for example, the I don't remember if it's the Giants or the Jets, but if the local football team in New York, near New York City, they actually play in northern New Jersey, Palisades Parkway. Whenever there's a football game, that area is very, very jam-packed. So if you were to enterprise to get a Lyft or an Uber ride at the stadium or near the stadium, when there's a game, it's going to cost you significantly more. And they can do that in real time, because in real time, they can look at the demand, the number of requests that are streaming in through the servers that supports their platform. Okay. Any other questions? Any questions? Does that make sense? Yeah. And so floating out there on the internet, it's no secret, is a so-called pitch deck. And a pitch deck, if you're unfamiliar, whenever a new company is trying to get lots of money or capital in order to grow and expand, they go to a set of people in the so-called private equity market, meaning private money, not public money like a stock market. And they go to a so-called venture capitalist. And the pitch deck is a slide presentation that they give to those individuals to try to encourage them to float them some money. Now, this money isn't given, it's invested. And so they expect an increase in return based on that portion of the company they purchase, so to speak, in exchange for providing them funding. And in the original pitch deck for Uber, it was called Uber Cab. And the idea was that by using these independent contractors, you had a variety of automobiles. So you could have minivans, you could have sedans, you could have station wagons, you could have pickup trucks, and all sorts of different types of vehicles. But also, because they're independent contractors, they were more responsive, right? And so this idea of responsiveness, if you've ever called a cab company, sometimes it takes a long time to get a ride because there's high demand. Now, of course, if you live in an area like New York City, where there are a lot of people, conceivably, you're going to have theoretically a higher number of cars to supply for rides in this ride hailing service. And so there are fewer licensing requirements for being one of these gig drivers. You have a basic background check. It's basically a glorified credit check with a little bit of check for criminal history, but it's not as thorough as what happens to the cab drivers. They have background checks, but they also are vetted for driving safety, driving standards. There's training provided. And then as a colleague, they get to know you as well. So that's a semblance of knowing someone's background. And so there's a big debate between the traditional cab companies and these ride hailing services, these gig based, these aggregation services like Uber and Lyft. And it has to do if it's fair, because the standards that are required of traditional cab companies are not the same standards that are required of these aggregation services for ride hailing, like Uber and Lyft. Okay, any questions about this? Does that make sense? Yeah. And so, of course, in Project 4, and I'm going to score the written part as homework too, this is going to require a lot more thought, akin to what we talked about defining an issue, looking at the system under study, determining who are the stakeholders for the ride hailing industry in New York City. And these are going to be users of the system. Who are they? They're going to be operators of the system. Who are they? And they're going to be managers of the system. One interesting user of this system that I remember when I was in Delaware, somebody used Uber scheduled to get their kid to school in the morning. I was like, oh, that's different. I don't know if I would do that, but it's an idea. It's expensive, and your taxes are already paying for the school bus. But hey, go figure, it worked for them. Then we're also going to look at, or you're going to look at the stakeholder impact. How does this system, what is the impact of the system from the perspective of each one of these stakeholders? The users of this ride hailing system, whether yellow cab or aggregation, the operators and the managers. Now, of course, the data set just talks about the rides. It doesn't talk about specifically the individuals. And it's very typical or not uncommon for these aggregation-based services like Uber and Lyft for someone to participate in multiples. So we don't have that data, at least not in the TLC data. Question? You're your own boss. So I'm just going to say the question, so I'll make sure I'm understanding it. Um, so the question is, if they're independent contractors, would they be the boss because they decide about what they're going to do for the ride? They can't carte blanche, as my understanding is from reading stuff. You can't decide every aspect of a ride. There are certain standards that you have to adhere to when you provide a ride in Uber and Lyft. You bear the responsibility for the maintenance of the vehicle, but the money comes in through the app, and you get your money after they take their cut off the top. And so it's this weird thing when you think about who the manager is. It's important to think about what's going to happen in terms of the ride itself, contacting the public, but what happens on the back end in terms of Uber, because Uber, they can decide regardless of what you think as your own business owner, they can decide to pull you off the platform and you're done, right? So in a sense, you manage certain aspects of it, but you don't own the whole service because your participation in the service means your agreement to the terms set up by Uber and Lyft, and they can decide to yank your participation if they choose to. And so that's a really good question. And when you talk about who is the manager, that's one of those instances where your cohort might be overlapping, right? You could have a manager who's also a driver. You could have a manager who's only a manager. You can have a user. And so it all depends on what perspective you're choosing to adopt in your representation. Another question? Yeah. Mhm. It depends if they can just pull you off the platform. It depends on what your population looks like for the question you're trying to answer, right? And so if your question pertains to corporate profit, and um, how that changes and how much money they take off the top versus the driver, and how that impacts potentially their ability to earn money, then the manager would be the corporate entity. But if you're talking about perhaps, you know, level of service and how that impacts the ability to collect revenue and tip income, then in that case, your manager would be the independent contractor. And so it's just kind of like Amazon delivery drivers, right? They're independent contractors, but they're participating in this system. And those sort of debates are precisely why there was litigation in California. And in fact, if I can't remember what the proposition was that they voted on, but the idea was to classify all of the drivers as Uber and Lyft employees and not independent contractors, because they don't have full decision about what they do, in the same way of if you hired a plumber or a carpenter, right? And so some places, some municipalities say yes, they're independent contractors, and you're just sourcing that business. So, for example, like when you go into a Home Depot, if you order a flooring contractor, Home Depot is just taking that request and sending it out to a contractor, right? But in this case, the contractor, they decide how they're going to do the work. I mean, you say, I'd like this flooring installed, and they decide how they're going to do the work and what their schedule is. But certainly, if they do something particularly bad, there's recourse. You can come to Home Depot, and Home Depot can choose not to push further business to that particular contractor. They're more of an independent contractor, but the argument in the state of California is that they're really employees because they don't have full decision about what they're going to do in terms of how they provide that ride service. And so it really is, there's no cut and dry way of thinking about it. You could think of it, and some states do this and some locales do this. You could think of them as true independent business owners, because they can join the platform whenever they want to. Or you could think of them as kind of this hybrid where they're both employees and managers. Does that make sense? Yeah. Other questions? Yeah. Sure. And then we'll get to your question. Hmm. Ah, yes. Uh-huh. Yes. Uh-huh. Yes. If you state your assumptions and support that with information. And so for this project, and we'll get to your question in a moment, for this project, you're going to be finding, there's an example article, but you're going to be finding two articles that are in support of the traditional cab industry, and you're going to be finding two articles that are in support of the aggregation ride hailing. But it's up to you to make that decision, because that's going to shape the type of question that you pose, which you then enterprise to answer through analysis. And so it really is more of that design problem. But in this case, you don't get to design the samples, right? If we had about a year and a lot more resources, we could spend a whole semester designing the survey and then going out and conducting the survey. Now, in that case, you get to select the individuals, the time, the venue, the location, etc., about where you get that data and how you get that data. But in this case, we're just given the data, and I'll talk about what the data fields are, and using this idea of population design to help shape what sort of question you're gonna ask. And so we're just using it for that purpose. But absolutely, it's very interesting. It's very complex, and it's not crisp like you'd get in many other types of disciplines. You have to make an assumption, and on the tail end, someone can have that debate about why did you define it this way. And the important part is to be able to support the why, right? Because at the end of the day, you have to make a decision, support the why you did it this way before you ask the question and go off and do the analyses. And this is more what it's like in the real world, right? The real world is a lot more messy. There's a lot more shades of gray, so to speak, in just about everything. Yeah. Did I answer your question? Or your question? Mhm. Yes. Yes, Uber, you can kick them out of the ride for reasons that you choose. And so again, that's another point, and thank you for that. It seems like you're more of an independent contractor in Uber because you can choose to fire your customer, so to speak, which I kind of like too. But anyways, um, any other questions? Okay. And so, ooh, one of the things that you're going to have to do for part of this, and I strongly recommend, I'm always paranoid about this thing dropping the connection. Let me just make sure. Yeah, the mic is still on. Because when I get to right about over there, it drops the Bluetooth connection. It's supposed to be 40 feet, but it's never works that way in practice. And so out of the box for the Jupyter Notebook, you don't get support for loading the type of file format they use for the NYC TLC. This file format, Parquet, or Parquet, if you want to pronounce it that way, um, is a binary format. So if you try to get a text editor and open it up, you're going to see what looks like someone vomited characters on the screen, right? It's just going to be gobbledygook. It's a binary format because it's a lot more efficient for storing data for size as well as speed in how you access each one of the columns in your data frame. And so out of the box, there's not support for loading Parquet files. And yes, when we talked about ingesting data in Pandas, one of the data sources that you can read from or write to is Parquet. But in order to support that, you have to install the libraries that have the implementation for reading and writing this binary file. And so in your Anaconda environment, you're going to be installing one of the two, not both, either PyArrow or so-called Fast Parquet. Now, when you install these, okay, you want to make sure that you're in your Anaconda environment because when it loads it, it associates the environment name with all of the tools that you load for it. And so you say conda space install PyArrow from the command line. And I know there's a graphical way in a browser when you log into Anaconda website to do that, or conda install fast parquet. Now, this might not always work for various reasons. It depends on your operating system version that you have. And if it doesn't work, you need to tell the Anaconda to load these libraries from a different location, different from the default location that it uses. And this is called a Conda forge, Anaconda forge. A forge is nothing more than a repository or a server that has a database of information, one of which are the libraries associated with processing Parquet files, either fast Parquet version or PyArrow version. And so after you do that, you're going to visit, and we'll do a drive-through today. You're going to visit the New York City Taxi Limousine Commission website, and you're going to read the so-called data dictionaries associated with the yellow cab, as well as the high frequency for hire vehicle. For hire vehicle is a nomenclature they've adopted for these aggregation-based gig ride-hailing services. And so these data dictionaries will go through all of the fields and tell you what the fields mean and what their values are and what these values mean. And the time you spend is going to be significant for this. In any sort of data science problem in practice, you're going to be spending at least about 50 to 60% of your time just understanding the data. And so my purpose today in talking about all of this is to bootstrap that with information about the ride-hailing domain, about New York City and the TLC. Okay, any questions about this? No? Part of your consideration is what columns are of interest. For example, you might enterprise to answer the question about fairness. And to talk about fairness, maybe you might want to talk about some semblance of revenue or tips or something like that. Now, of course, if a trip is more lucrative, it's going to have a bigger dollar value per mile driven. So in order to calculate something like that, you would want to take the number of miles driven, both per trip or maybe on average, and the amount of money collected, the fare, and you compute that proportion, normalizing it to something that you can use to make comparisons. But it's entirely up to you what columns you use and what transformations you make on it. You could choose to have a distribution that says, okay, well, what is the most frequently visited location? One of the pieces of information, and we'll go over that in detail, is the so-called zone, right? They chop up the geography into zones and they give them names. And when you do a fare, it has a pickup location, which is in one zone, and a drop-off location, which is in another zone. The rates can be different depending on the venue. When you pick up at the airport, well, they want in on the profit, right? They charge airport fees. And when you're at an airport and you hail a cab, they try to make it fair because it's a captive audience. And for traditional cabs, they generally have a lane. And this lane, these cabs queue up in line in the lane. And anyone who comes out of the airport and needs a cab ride, you take the cab at the head of the queue, and then they take you to your destination. Let's see. So you're going to get for this assignment 1 year's worth of performance from the most current year, and it's not up to 2023 right now. It ends in 2022. I think it's November, and you're going to get the most recent year of performance data. It's reported 1 month at a time. You're going to do your analysis. You're going to pose your question. You're going to recruit your data. You're going to stitch together data files. You're going to visualize. You're going to compute things. You're going to answer your question based on what you've computed. But in this case, it's the time spent on the data, designing your population, adopting a posture of some cohort in your population, and then using that to pose a question, which you then recruit certain columns in order to answer that question. Does that make sense? Okay. So let's take a look at, why did I have this one? Ingesting. You can certainly read Parquet files, and it goes with the general scheme, like how we had read underscore CSV. For Parquet files, it's read underscore Parquet in the Pandas module. You give it a path name to the Parquet file, like here, nyc.parquet. And then when you look at the data, these are the two websites. It's also in the assignment, the main website for New York City Taxi Limousine Corporation and the data website for the so-called trip records. Likewise, if you want to write out a Parquet file, let's say you do some filtering from the original unmodified files, you might want to write out that result so that you don't have to load the original big data file each time you want to continue on. And so it would be PD dot to Parquet, and the general schema is to underscore the name of the file format, and the general schema for reading is read underscore followed by the name of the file format. Does that make sense? Any questions? No? All right. And so you set up your environment, and you're going to install one of the so-called runtime engines, the libraries for Parquet, within your Anaconda environment so that you have them defined when you're running your Jupyter Notebook. And you might need to try different repositories. And these repositories are databases on servers. And I have some URLs for those instructions in the assignment, because sometimes based on the system that you're running, it might not install from the default repository. And so you might need to do that. So then you install one of the Parquet runtime engines, either Fast Parquet or PyArrow from your Anaconda environment. And when you do that, it's going to ask you a bunch of questions. You want to answer yes to those questions. And when you're done, it'll tell you, and you're now able in your Jupyter Notebook to load Parquet files. If you do not install the runtime engines, you'll get a syntax error that it does not support that file format. So it's really important to make sure that you're set up in your Anaconda environment with the runtime engines, either Fast Parquet or PyArrow. Which one should you install? There's no real difference between the two. Fast Parquet has a nice sound to it. Oh, it's fast, you know. But they both have timed them. They both are roughly the same performance. Okay. You'll also need to make sure you have a stable internet connection, because when you do these installs, it's going to fetch from these servers across the internet these runtime engines. They're not big, but if the internet connection wherever you are is not very good, it's going to be an exercise, unfortunately, in frustration. Also, you want to make sure you have a good internet connection or stable. I don't know where the best ones are, but more generally, when you're downloading these Parquet files from the NYC TLC site, they're going to be quite large. Again, total data is going to be between like 5 GB and 10 GB, bigger than what you're probably used to working with in any class. Okay. Now, as far as data sets go, from an industry perspective, 5 to 10 gig is a large data set, and these records label in the millions. But it's not enormous. There are 100 gigabyte data sets for things like satellite imagery and weather and stuff like that. So it's not necessarily big data. I'd say it's bigger data from what you're probably used to dealing with. Okay, and so you only need to install one, and then the quote unquote hello world exercise is to bring up a Jupyter Notebook and just test that you can load a Parquet file and then verify that it's actually loaded by just displaying the first 5 elements, head or whatever you're choosing to do. All right. Any questions? Does that make sense? All right. So let's pop out. I won't play the music again. I'm going to stop the share and let's go into the Jupyter Notebook. Let me share screen and let me, let's see, Safari. Okay. So let me bring this to the foreground, hide the meeting controls. So these files are fair. Oh, you know what I was going to do? That's what I was going to do. I knew there was something else. Let me share screen differently. Let me get rid of my slides. Let me go back to Zoom, share screen. I wanted to show you the TLC data set. It's Firefox. Which one is that? No, what's this one? This is the other Firefox. TLC data. I have 2 Firefoxes. Okay, so let me share both. They don't know which one is which. Is there another Firefox? No. 2 Firefoxes. All right. Let's minimize that one. And let's bring up that one. Okay. So if you go to hide load meeting controls, all right. If you go to the main NYC Taxi and Limousine, oh, that's nyc.gov. I didn't mean to do that. Okay. TLC. Let me just do it that way. Okay. Nope. NYC TLC. There we go. All right. So if you go to the main Taxi Limousine Commission website, you're going to want to go to the download data section, and then you want to look at TLC trip record data. And if you scroll down, you'll see it's indexed by year from the oldest year to the most current year. And so the most current reporting period is 2022. So we'll expand that, and you'll notice for each of the months, in this case, January through November, it has a bunch of different file types. The types that you're concerned with are the high volume for hire vehicle trip records and the yellow taxi trip records. If you download, it's going to download a Parquet file in a stylized format. It'll have a name. It'll have the month encoded and the year encoded. And so if you try to use the most recent year's worth of data, in this case, it's going to straddle 1 month in 2021 and go to November of 2022. If you find that your system is just completely choking on the size of the data, you're welcome to shorten it to 6 months. And there are also algorithmic considerations for subsampling in order to make the data set physically smaller. And so importantly, of course, is the data. Well, if we scroll down, we have the so-called data dictionaries. And these data dictionaries, let me blow that up, are the sort of manifest that describes what these data sets are and what the fields in the data sets mean. So let's go ahead and let's go to the yellow trips manifest or dictionary. And here we have two columns. The first column is the field name. And when you ingest the data into a data frame from read parquet, it's going to set the key value for each one of these dictionaries for the data frame resulting to this particular field name. And so we have, starting out, the vendor ID, and this is for the yellow cab. There's a separate one for the for-hire vehicles, and you want to make sure you're using the high-frequency version. The vendor ID corresponds to the transponder. In each cab, it's sending live data through the cell phone data network to the cab company and ultimately to the TLC, Taxi Limousine Corporation. There are two major vendors for the telemetry, and it's important to them to know which particular vendor's telemetry equipment was responsible for sending this data over the wide area network back to the home office, so to speak. There are two fields, the pickup time, TPEP pickup date time, TPEP drop-off date time. That's a Python date time object. And so it has a date portion and a time portion, which we had talked about. And this represents the time when the meter was engaged. And so you hail a ride in a yellow cab, and we're talking about yellow cabs specifically. When you get in, you tell the person where you want to go, and I'll say, okay, well, and they turn on the meter. Now that's the timestamp associated with when the fare officially started, because this meter operates at a cadence based on time and distance. It increases the amount of money you're paying ultimately. And so that's a date time object, both for the time when the meter was engaged, and at the end of the fare, when you arrive at your destination, they turn off the meter. And that's also the timestamp represented as a date time entry for that column. We also have the passenger count. One of the things that gets recorded is the number of passengers in the cab. This is taken on honesty, but a cabbie wouldn't want to be disingenuous about this, especially because if the cab is overloaded and you get into an accident, people get in trouble, and you wouldn't want a cab driver to compromise the medallion of the cab company owner. Okay. Any questions about this? No? All right. So then we also have the location ID for pickup and for drop off. And this corresponds to the zones in which the taxi was engaged. There's a separate file on this website, another dictionary that explains and talks about the zones. And it's basically taking the geography of the city, carving it up into regions, and each region is given an identifier. Likewise, we have the rate code, and the rate code corresponds to different special locations. Anything that's not a special location gets the standard rate, and that sets the cadence appropriately for time and distance, because they scale it up and scale it down depending on certain places. So the reason they do that is because some places are more expensive to drive through. You go through tunnels, you have to wait in lines, it takes longer, and you also have special fees in order to pick up at some of these locations, like airports. So JFK corresponds to John F. Kennedy Airport, which is in New York City. Newark is in New Jersey, Newark Airport. It's one of the larger international airports. In fact, out of Newark, you can fly just about anywhere, Bali and all sorts of great places. Nassau Westchester, which is upstate New York, and other places, and other types of rates. So then the store and forward flag, that's something that's important to the TLC. And when you have these telemetry boxes and you beam or send this information about the ride back to the server, sometimes you have a connection. Other times, like when you're in a tunnel, you don't have a connection. And so what does it do? It takes that information, it stores it locally in the storage for this meter. And then when it reconnects, it takes the opportunity to send that information. And so this information for store and forward asks whether it was held in memory before it was sent. Did it have a network connection when it was ready to send that information? Okay, and that's important to them. Then there's the payment type, okay? All sorts of payment types, including things like avoided trip, things that are in dispute, or there was no charge for whatever reason. Then you also have the fare amount. That was what was calculated, time and distance. It'll just give you a dollar amount that was calculated for the ride. And then you have a bunch of extra surcharges, things, let's see, if it was overnight, rush hour, and there were various reasons why they do that because it's harder to get employees to work overnight. Then you also have taxes. The Metropolitan Transportation Authority has a tax, and that's based on if you're using the roadways, you have to contribute to the care and maintenance of those roadways. Potholes are a real thing in any sort of urban environment, especially in the Northeast, like New York City, where you get snow events and that can accelerate potholes and degradation in the road service. You also have improvement surcharge. I'm not sure why this is here. You can search for it. But there are lots and lots of different fees and things that people assess on cab rides to pay for and finance all sorts of different things. Then, of course, if there was a tip, what is the tip amount? If there are tolls, the tolls have to be paid by the taxi, and that is passed on as a cost to you, the consumer. It was the total amount that was charged to make sure nothing funny is going on. Then there's also these congestion charges, airport fees, and so forth. Okay, any questions? No? Make sense? All right. And so in similar fashion, we'll take a brief look at the high volume for hire vehicle data. And it has a lot of the same fields, except the license number is one thing that's different. And here, what you'll see is one of these values, and this value, like HV0003, corresponds to an entry in this license number field for Uber. And so if you wanted to do your analysis for Uber or Lyft, Juno and Via, which are smaller, but they're still operating in the city, you would want to do the filtering. And so you would build a new data frame, filtering out those records that correspond to Uber, and then you could choose to write that down as a Parquet file for loading next time, so you don't have to do this processing over and over again. And so here, you're going to be extracting a particular ride-hailing service. This file is absolutely enormous, and I'll show you an example of how many records they have. It counts in the millions. Then you also have things like the pickup and drop-off, which is important. The zone, pickup location, and drop-off location. You have the base number. That's important to the TLC, not necessarily as important to you as the zone and the time and the distance. You have, this one is interesting, when the passenger issued the request to be picked up. Because what happens with these ride-hailing services like Uber, the request comes in, you get the request at one time, you drive to the area, and then you're in the area trying to find it, and then you pull up, and then the person gets in and the ride begins. And so there's the time and date time when the request came in. There's the date time when you were in the area for some proximity to the pickup area. And then there's actually when the fare began, right? They record all of this data. And certainly, excuse me, the time spent that transpires between the request time and the on-scene time, and the on-scene time and the actual fare begin time, the pickup time, that's time when you're not making money, right? Certainly, you're burning gas and you're burning your time, and you're not making money during that time. And so if your consideration was how profitable it is, for example, and you wanted to count the amount of dollars collected for the time that is worked, it's up to you to choose if it's the total time spent or if it's just the time for which the fare was being delivered. Does that make sense? Any questions? No? All right. And then you have the usual surcharges, you have airport fees, you have the total driver pay. And this goes back to this point about if they're employees or independent contractors, because Uber and Lyft, they get their cut and the driver gets the difference. And then there's also the tips and the shared request. In these ride sharing platforms, you can choose to share the ride with somebody, and that's a feature. And so how you choose to talk about maybe dollars per passenger, maybe dollars per mile. Depends on, in part, on whether the ride was shared or not. Okay. Any questions about this? And there are a bunch of others that aren't quite as important. Do they request wheelchair accessible? That's a really important one. And that's actually one of the positive arguments for these aggregation-based sharing, ride hailing services, is that you can have a much higher variety in passenger transport. So you can have child car seats, you can have, wheelchairs and stuff like that. You could even say, I'm CPR certified and I can take wheelchairs. And they won't let you charge a premium for that unless you're what's called Uber Black. Uber Black is kind of the more fancy service, and they charge more because they give more amenities, including the type of car that is required to get. Anecdotally, a friend of mine used to, whenever he visited his family in Washington, D.C., he would string together Uber driver rides from like somewhere in Boston or Springfield to Hartford, and then Hartford to another city, and then to another city, Wilmington, Delaware, and then to Washington, D.C., giving people rides over longer distances, and he'd get paid to drive home to visit his family. Hey, works for him. I thought it was pretty clever. And you also have company for the ride. But anyways, so this is the high frequency for hire vehicle data set. So I'm gonna, any questions? No? All right. We have about 3 minutes. So let me minimize this one. And I'm going to bring up, stop the share. And I'm going to bring up Safari. And here, hide meeting controls. Did I do that right? Yeah, that's shared. Okay, I see the green box on my interface. Let me hide meeting controls. And here, I've already installed an Anaconda. I can't remember if it was Fast Parquet or Payara. I think it was Fast Parquet. So as usual, I import the library. I give a path name to the trip data. Here I have January 2022 and February 2022 for yellow cab, and then I have high frequency for hire vehicle for January 2022. I will read these, and you notice it's taking some time. It's not instantaneous like you're probably used to. And as I stall for time while it's loading, chug, chug, chug. I have, I think it's 16 or 32 gig of RAM on my laptop. And one of the things that's important, if you have one of these kind of so-called ultra light, ultra portable laptops with like 8 gig of RAM, your system might struggle to do this in a Jupyter Notebook. Some solutions are, if you do it as a regular Python program, it doesn't bring in all of the heft and the memory requirements needed to run your browser and all the other stuff. But in a pinch, you can always just kind of pivot, and instead of 1 year's worth of data, take 6 months worth of data, or bring in one Parquet file at a time, filter out of it what you need, and then write it back as a smaller Parquet file, and just dealing with 1 month at a time, constructing what you need. So here, let's take a look at the yellow cab data. We're going to look at the first 5 entries, and just as we had talked about, and you'll notice that when you look at it, some of these entries are not a number. And so you're going to do the usual data cleaning. But if it's something like a vendor ID, can you really substitute the mean, right? Because the vendor ID is really categorical, even though it is a numeral, right? So you want to make a good decision for what you do. In that case, it's most likely dropping that record from consideration. And so here's yellow cab, the tail of it. You'll notice here, passenger count is not a number. For something like passenger count, of course, you don't have fractional passengers, right? So you want to make a decision. If you do the data cleaning, are you going to round up, round down, substitute the mean, drop those records? What are you going to do? But more importantly, what is the implication for what you do? So here, I'm going to slice out the vendor ID, and the vendor ID, I said, corresponds to the transponder. So it's either 1 or two. Let's take a look at the high frequency for hire vehicle, and you can see the license number for the first 5 entries is HV0003, which is the license for Uber, and you have all of the other records. Here we have the pickup and drop off. That's a date time object that we talked about. We can also look at the tail. I'm going to slice out the license number. You could perhaps do a histogram of that to see how many are Uber versus Juno versus Lyft and so forth. And you do a head and a tail, and I'll end with this. I'll plot the shape. What just happened here? Yellow cab 3. Of course, maybe I skipped the cell. Yeah, I skipped the cell. If we look at the shape, you can see it's 2.4 million records. We have 2.9 million records. I do a concatenation. We have about 5.4 million records. So it's a much more complex data set. And I will end here. We are a minute and a half over. I like to be on time. So we'll end there, and I'll do a little bit on Friday before we pivot to the other material, okay, with filtering. So if you have questions, I can answer them afterwards, but we'll end here. And I will see you all on Friday.